All right, 4.3 is all about similar polygons, which is kind of the main focus of this unit. All the other things we're just using to do this. All right, so similar polygons. Polygons, what are polygons? Polygons, just as a reminder, polygons are shapes that do not intersect and they have no holes. So polygon, that's not a polygon. If you can tell me why that's not a polygon, I'll give you bonus points. Polygon, not a polygon. Not a polygon. Got it? All right. Similar polygons have the same shape, but not the same size. They have the same shape, but not the same size. So they're similar, but not equal. Got it? Polygons are similar if, and it has to meet both of these criteria, if corresponding angles are congruent, right? The angles have to be congruent, and the corresponding sides are proportional, right? So if this is a 4, then this is half the size. It's a 2. They are in proportion. So it has to have congruent angles and proportional sides. It has to have congruent angles and proportional sides in order to be a similar polygon. All right? The ratio of corresponding sides is called the scale factor. That should look familiar. We use our variable k for scale factor, right? So the ratio is our scale factor. So far, our scale factors have all been fractions. A ratio is just another way to write a fraction. Yeah, okay, stay with me. If polygons are similar, meaning it meets both of these criteria. Criteria. If they are similar, then their perimeters are also proportional. So if the perimeter, what's perimeter? Okay, I'll put it up just in case. Perimeter, the continuous line forming the boundary of a closed geometric figure. It's the outside. The perimeter is the outside, right? So if the perimeter of this triangle is 16, and this is half of its size, then the perimeter has to be 8. They're proportional. So if it meets these two criteria, then the perimeter also follows the scale factor. This is important information. I'll show you why. I'll show you. All right, so quick back look at scale factor, just so we can see how it works with what we're doing now. Right? What is the scale factor of triangle ABC to triangle DEF? How could you figure that out? How could you figure that out? How could you figure that out? All you have to do is pick one side. Let's do this side. They are the same. Let's do this side and this side. What is my ratio? From here to here. And yes, the order matters. Do ABC first. Why? Do this triangle first because it told you to do it first. So, if we're going to use this side, that's an 8. And we're comparing it to 12. 8 to 12 is the ratio between this triangle and this triangle. 8 to 12. Could have I used 10 to 15? Yes. Could have I used 14 to 21? Yes. Just pick a side. Find two matching sides. And that's your ratio. Can this be simplified? Yeah, they can both be divided by 4. So it's going to be 2 to 3. So the scale factor from this triangle to this triangle is 2 to 3. Or as we might be used to seeing it, your K is 2 over 3. Let's do another one. What is the scale factor of triangle DEF? This time it wants us to start with this one. Make sure you start with the correct triangle. Order matters. From this triangle to triangle ABC. Again, let's just choose two sides. You want to use the same two sides? No. Yes. Do we want to use the same two sides? Why not? All right, so this time we're going from this triangle, 12, to this triangle, to 8. Simplify it again. This time our ratio is 3 to 2. This is why order matters, because your answer is going to come in the order you did it. So if you have to start with the bigger triangle, you need to start with the bigger triangle. It matters. All right, and then it says, what is the ratio of the perimeter of triangle DEF to ABC? So we just learned again what perimeter was. What is the ratio of the perimeter? You have to ask yourself, which triangle is it asking you to start with? It's asking you to compare the perimeter of this triangle to this triangle. We already know the ratio. It's the scale factor. It's the same answer. If they wanted you to go 1, 2, which they did, 1, 2, right? This one to this one, then this is your answer. If they wanted you to go from smaller to bigger, this would be your answer. You already have the answer. You just have to make sure you're getting it from the right triangle first. This says do triangle DEF to triangle ABC. Just make sure you're going in the right order, and you'll already have your answers. Let's do that just a little bit deeper. All right, so similarity statement, right? We're looking at similar polygons. We need to know how to write that, right? So a similarity statement tells me that they're corresponding angles, they have proportional sides, and that they share a scale factor. So if they are similar polygons, then you can write that. And how do you write that? This is the symbol you use for similar. If it is a valid similarity statement, it must match the corresponding angles and the sides. In order for it to be valid, in order to be considered a similar figure or a similar polygon, it has to match that criteria. But if it does match that criteria, then you can say triangle ABC is similar to triangle DEF. Not equal, not congruent, similar. Similar. On the keyboard, it's all the way on the left-hand side below the escape button. It has like a wavy line on top. But that's how you would write it. Triangle ABC is similar to triangle DEF. All right, and then let's figure out how to use it. List all congruent angles and write a proportion that relates to the corresponding sides. We're going to write a fraction, right? We're going to write our fraction, our proportion, AB equals CD. We're going to write our proportion that relates the corresponding sides. It tells us triangle JKL is similar to triangle PMN. We know that means two things. We know the angles are congruent, right? The angles are congruent and sides are proportional. Right? We know this. It just told us this. If it's using the similar symbol, then we know this is true. Right? We can use that knowledge. We can use that knowledge. Let's look at our angles. Angles are congruent. They have to be. It just told us they are equal. So you need to figure out what angle does this match. In my head, what I like to do is, if I had to move them around on top of each other, what letters would stack? So if I wanted to move this shape, rotate. If I wanted to rotate this shape to match, the K and the M would be in the same place. That means that angle K is congruent to angle M. Congruent. Remember congruent? Which other ones match up? Let's change colors. If I was rotating it, it looks like the J would land on top of the P. So that means angle J is congruent to angle P. Right? I'm just matching them up. We already know they're similar, which means we know the angles are congruent. We just have to figure out which angles are congruent. Right? And then that means angle L and angle N are going to be congruent. Angle L and angle N are our congruents. It asked for the congruent angles. There are 3 angles. You should have 3 congruent angles. And then it says sides, because remember, the original directions asked you to write a proportion that relates to corresponding sides. It's asking for a proportion, which means we're going to create a fraction equal to a fraction equal to a fraction, because there are 3 angles. It's an extended ratio. Right? So, what can we learn by looking at our sides? What can we learn? We know they're proportional, so let's number them. Right? Let's number them. What is this side called? This side is JK. Right? This side is KL, and this is JL. We labeled our sides. It's going to help us. Right? This side is PM, this side is NP, and this side is NM. Does order matter here? No, because they're corners. There's only, it doesn't matter, it's going to be the same. I always put the letter on the left. Should you? Yeah. It will help you draw the shape if you have to draw the shape. If the order on the left is your first, you'll know that that's the letter up there. You decide. All right, so same thing. Imagine you rotated it. Where does this line match up? It would land right here. Right? That means that this and this are proportional. This fraction is equal to this fraction. This ratio is equal to this ratio. No? One is bigger, one is smaller. These are the two that we're comparing in our ratio, two quantities. So you could write it two different ways, right? Write it like a ratio or write it like a fraction. So JK over PM Why did I start with JK? Because it came first. This triangle came first. Or you could write it like a ratio. JK to PM. That's the ratio. This time we're going to do KL Come on. That's not frustrating. Okay, I think I saved it. All right. I'm going to draw this here so you know this is a fraction bar. But again, we're just comparing lines. We're comparing sides. So the side ratio, KL, because this triangle comes first, to NM. And the last one, see how I do it in my head. Feel free to draw colored lines. It really will help. They will label. All right, so the last one was JL and NP. So let's do JL over NP. Whether you do it as a ratio or a fraction, it's 100% up to you. It's 100% up to you. And if it's too much information, draw it without the lines. What was our first one? Orange. JK over PM. Right? Is equal to, because we're doing proportions, so we need a fraction equal to a fraction equal to a fraction, extended, right. And then our blue one was KL, NM, KL, NM. It does look a lot less cluttered without the segment. That's right. Do whatever works for you. And then JLNP. Right? These are our ratios, our corresponding sides. Make sense? A little? Let's do another one. All right, one more. Same thing. List all congruent angles and write a proportion that relates the corresponding sides. Same thing. Proportion. AB equal to CD. We're creating ratios. Equal fractions. Equal ratios. Because we know it's similar, we know that the angles are congruent. We just have to figure out which angles are congruent. So let's look at it. We're starting with XYZ, which is this one. Looks like we're starting with the bigger triangle. And then we're similar with RYS, which is the smaller one. So we're going bigger to smaller. Good to know. So now we have to figure out which angles correspond. They're already stacked. This one should be super easy. This angle is congruent to this angle. X and R. Angle X is congruent to angle R. This angle is congruent to this angle. You see how these ones have one line? That means they're congruent. These ones have two lines. That means they're congruent. All right, so that's Z and S. Angle Z is congruent to angle S. I'm saying angle. So if you're not listening and you're writing L, I'm going to mark it wrong. Because I'm saying angle. And you're supposed to be listening. And lastly, this angle is congruent with itself. How would you write that? Angle Y is congruent to angle Y? Yes, yes you would. Angle Y is congruent with angle Y. All right, angles are done. Now we got to look at the sides. Remember, because it's similar, the sides are proportional. All you have to do is figure out which sides you're comparing. So this long one here is XY, and this shorter one here is RY. Oh my goodness, that was hard. Okay, so XY, RY is our first ratio. And then we have, remember which one comes first. It said the XYZ comes first. The bigger triangle is coming first. So we're going to go ZY, and then we're going to go SY. Lastly, bigger triangle first, XZ or S. That's it. All it wants you to do is recognize that because they're similar, the angles are congruent and the sides are proportional. Congruent, proportional. Literally, that's all it wants you to do is recognize that they are the same shape, just a different size. Why does that matter? Because if you know the values of the smaller triangle, you can use that knowledge to figure out the values of the bigger triangle because they're in proportion. That's it. That's all for 4.3. Practice sheet and mastery check should be ready to go. Good luck.